Imagine walking through the forest and suddenly seeing a snake in the grass. You might freeze, jump back, or feel your heart race before you even realize what you saw. But why does your brain react so quickly to something that, today, usually poses no real threat? The answer goes back hundreds of thousands of years. In this video, you'll discover the real reason why humans fear snakes. Your reaction wasn't a choice. It happened before your thinking brain even caught up. That gap between the jump and the realization is where the story begins. Scientists have a name for this. It's called the snake detection theory. Primatologist Lynn Isbell proposed it in 2006, and it argues something strange. It argues that snakes didn't just scare your ancestors, they built parts of your ancestors' brains. And here's the plain English version. For tens of millions of years, snakes were one of the only predators small enough to hide in grass, fast enough to strike without warning, and dangerous enough to kill an adult primate with a single bite. Big cats could be seen coming, snakes couldn't. That made them a very specific kind of threat, a threat that rewarded speed over accuracy. Think about that trade-off for a second. If you're a small primate and you misidentify a stick as a snake, you waste a second of energy jumping back. Annoying, but survivable. If you misidentify a snake as a stick, you don't get a second chance. Over millions of years, that asymmetry shaped something inside your skull. Your amygdala, the almond-shaped structure buried deep in your brain that handles fear. Isbell's research suggests the amygdala expanded specifically because of predators like snakes, giving early primates faster visual pathways dedicated to spotting curved, coiled, patterned shapes in cluttered environments. Not because snakes were common, because the cost of missing one was catastrophic, and this isn't just theory. It's been tested. Psychologist Joshua New ran experiments where people were shown grids of ordinary objects, flowers, mushrooms, caterpillars, and snakes, all hidden among visual clutter. Across the board, people spotted the snakes fastest, not because they were told to look for them, because something in their visual system was already tuned to find them. Even babies show this. Researchers Vanessa Lobu and Judy Deloche ran a now-famous study with toddlers as young as 8 months old. They placed images of snakes among other images on a touchscreen. The infants, children who had likely never encountered a real snake in their lives, found the snake images faster than they found flowers, frogs, or caterpillars. Pause on that for a moment. An 8-month-old has no concept of danger, no memory of being bitten, no parent whispering warnings about the tall grass, and still, their eyes moved straight to the snake. That's not learned behavior. That's inherited architecture. But here's where it gets more interesting. Fear of snakes isn't fully automatic either. It needs a small nudge to fully activate. In the 1980s, psychologist Susan Maneka ran a series of experiments with rhesus monkeys raised in laboratories. These monkeys had never seen a snake in their lives, and remarkably, they showed no fear of one when they first encountered it. But when they watched a video of another monkey reacting with fear to a snake, just a few seconds of footage, they developed a lasting fear of snakes almost instantly. When shown a video of a monkey reacting fearfully to a flower using clever editing, the fear didn't transfer at all. What does that tell you? It tells you the wiring is there, waiting, ready to fire, but it takes a spark, a glimpse of someone else's fear, a single bad encounter, a story passed down to fully switch it on. You're not born terrified of snakes. You're born extremely fast at learning to be. This is sometimes called prepared learning. Your brain isn't a blank slate that treats every possible danger equally. It comes preloaded with shortcuts, fast lanes carved by millions of years of ancestors who didn't survive the slow lane. Snakes get one of those fast lanes. So do spiders, heights, and the dark. Cars, electrical outlets, and guns, despite killing far more people today, don't get the same shortcut because evolution hasn't had time to catch up to modern danger. That mismatch is worth sitting with. Your brain is running threat software that's several 100,000 years old on a body living in a world of asphalt, seatbelts, and smartphones. It's still scanning the grass for something that mostly isn't there anymore. Not because it's broken, because it hasn't been updated. Evolution doesn't patch software overnight. It takes generations, and the modern world arrived far too fast. So the fear you feel isn't irrational. It's outdated. It's a message from a version of you that lived somewhere far more dangerous, still trying to protect a version of you that mostly doesn't need it anymore. There's a deeper layer to this too. Some researchers, including Isbell, argue that the constant pressure to detect camouflage predators may have shaped more than just fear. It may have shaped attention itself. The ability to scan a cluttered scene and pick out one meaningful detail. That skill didn't disappear once snakes stopped being a daily threat. It just found new targets. A single typo on a page, a stranger's face in a crowd, a change in someone's tone of voice. The same fast lane circuitry, repurposed for a world that no longer looks like the savannah. That reframes the whole picture, doesn't it? The jolt of fear you feel at a snake in the grass and the way your eyes are drawn to the one wrong word on a page might be running on the exact same ancient machinery. Not every culture fears snakes the same way, either. Some societies revere them. Ancient Egypt placed the cobra on the crown of pharaohs. Some indigenous traditions treat snakes as guardians or symbols of renewal tied to shedding skin and rebirth. That doesn't cancel the biology. It shows how a fast, hardwired reaction can be shaped, softened, or even reversed by culture and meaning layered on top of it. The circuit fires. What you do with that feeling afterward, fear it, respect it, worship it, that part is learned. So the next time you flinch at something curved and shadowed in the grass, before your mind even forms the word snake, know what's actually happening. You're not overreacting. You're hearing an old alarm, one that once separated the primates who passed on their genes from the ones who didn't. Your brain kept the alarm, it just forgot to tell you why it's still ringing. And maybe that's the real answer to why you fear snakes. Not because snakes are common in your life today, but because somewhere in the long chain of ancestors that led to you, one of them looked down at the wrong moment and lived. That single moment of speed over certainty got passed down, generation after generation, until it became one of the fastest reflexes wired into your brain. You didn't choose that fear, you inherited it. And every time your heart jumps at a curved shadow in the grass, you're feeling the echo of every ancestor who jumped first and asked questions later.